Hello everyone, in this video we'll be discussing how to create SQL queries and execute them using SQL Alchemy on your server-side code. So to do that, first off you'll need to get a couple packages installed. Make sure you're in your virtual environment and within the server folder. If you are not, here's a way to get there. First, get to the server folder and make sure you have this venv folder there, and then you can say venv scripts activate, and then you should see this message next to the bash prompt. Okay, alright, so once we're there we can do pip install py-mysql and SQL Alchemy. And with that, you'll have the two packages we need installed. Next, you'll need a config.py file, like this one over here. I can't show you the content because it would contain my username and password, but here's an example. So you'll need a database._URI equals, and then this part will be the same, this first part. That is saying, okay, well, we'll need to connect to a MySQL database, and here's the additional connector that we'll need to use. And then afterwards, you'll need to specify your own username and password, and then the location of your database, along with the actual name of the database on there, okay? So in this case, if you're running on the localhost or on your laptop, then you would say localhost :3600, meaning port 3600, and you would need to give your username and password for connecting to that database. And then the name of the database, in this case, Barbier Drinker. Alright, the next step after that will be creating a database.py file. And here's what it will look like. You'll need to import from SQL Alchemy create_engine, and then also this SQL. And then we'll need to import the config that we just created, this config file. We'll need to import it so that we can get that database URL or URI. And we use it right here. So on line 6, engine equals create engine, and then we pass in that URL. So config.database URI should do the trick. And with that, now we can use this engine to execute different queries eventually. Ultimately, what happens is this engine connects to the database, and then on that connection, we execute the queries. One such example is this function right here, getBar, or getBars. So in order to execute a query, we say with engine.connect as connection or con.execute, and then you provide the query text, in this case selecting all the different columns from the bars table. So what we're doing here is we're just getting a list of all the different bars, and once we have that, that's referred to using this variable over here, rs, and we'll need to iterate over each of them and make sure it's a dictionary, because what we get is actually a row object, I believe, or a result proxy. So to do that, we iterate over every element of rs. We refer to each element as row, and then for each row we need to convert it into a dictionary using this function here to cast it. And then the overall list of all the elements, once they've been processed, will be returned as the result from this function. Okay, and then the next function, getBar, will take a name, and the purpose of this function will be to find all the information for a bar if you know the name already. So this is a great example of using a parameter within your SQL query. You don't want to do just blind string concatenation, because that is unsecure, and you would need to do a lot of escaped characters in order to make sure that it's safe. In this case, all of that would already be handled for you. So you would say SQL.text and then pass in your query. But note this last part right here, the where clause. I say name equals and then colon name. This will represent the parameter that needs to be plugged in. And then it's the same idea as before, con.execute query, except now you also specify the name. So the left hand would be whatever the name is for the parameter within your query, and then the right hand is whatever value you want. In this case, it's also called name, but from the function. And then whatever the results may be, we just need to get the first, so rs.first, and then we need to check if it's none. For those of you unfamiliar with Python, this is equivalent to saying null or undefined. So as you would check null in Java, we need to check for none in Python. And if it's none, then we'll just return none. Otherwise, when we do dictionary of none, it might throw an exception. So with that taken into account, we can return the dictionary, and that's it. And finally, of course, there's this example. So in this case, what we're trying to do is get a list of all of the different beers that are sold, and they're all stored within this cells table in our database. So we'll just do a select star from cells, and then where price is less than the parameter max price. And this max price will also need to plug in just like before. So max price is the parameter here for our function and also for our query. But now here's one additional step. So as you can see, everything builds on top of the previous portion. In this case, we're not going to be able to just return every row as a dictionary in the list, but rather we'll need to process first. And in our database table, the price column is stored as a decimal. But in our case, for Python, there is no such direct conversion, so we need to make sure it's stored as a float and then later on converted into JSON. So for every element in results, we'll need to go in and overwrite the value price to be casted as a float. And that's what we do here. This will take our .price and cast it into a float and store it back in. And afterwards, of course, we have to return the results. And then for the next portion, we'll need to create the REST API for all of these different requests. So make sure you have the JSONify, make response, request, and JSON imports, as you can see over here. The first three being from Flask, and then the last being just its own package. Additionally, we'll also need to import the database module that we created in the database.py file. That whole file, all the different functions, we'll be able to execute once we have this import line. And now, the first route will be like this. A couple key things here. First, the string here will specify the URL path for your API request. In this case, we need to get all the bars, and I'm just going to have it as /API/bar. And then the second key information is the HTTP method. So the HTTP methods really mean what type of request it is. In this case, it's a GET request. So our route here, our API route, will accept only GET requests with this URL. And typically a GET request I recommend for generic requests where you just need to do simple query and return. If you need to process a body of data such as input text and a bunch of other information from the user, all from a form, then you'll want to use a POST request, which I will also show you in a little bit. As far as this GET request is concerned, to get all the list of bars, we have a function called getBars, and what it will do is first it will execute database.getBars. That was this function right here. And then once we have the result from there, we'll just convert it into JSON and return it. So that's what this function would do over here. JSONify will serialize the Python object and then return it. Or if it's a list, then it'll be returned as a list. But that's how that works. And then here's a second example where I also show you how to have path parameters. So sometimes what will happen is you'll want to get information right from the URL. And the way to do that would be to get the path parameter as I show you here. On line 16, after API/bar, we include additional information. So it'll be /name. And this name, you're not going to type in literally name into your URL, but rather you can type in the name of some bar. And that's how we're going to filter and get which bar, get the details for a given bar. So that will, whatever you specify here within the carets, you'll need to put here. So if I were to say X here, then I would need to make sure my URL reflects that. So it would be like that. And then of course, this is also a GET request. There's not much data to really process through in order to do this. And then there's this whole thing. So in our try portion, the first thing I'm doing is checking if the bar is even specified. If it's not, then there's something wrong. So I need to throw an error. And to do that, we raise the exception value error, and we'll attach a message bar is not specified. Otherwise, the name is there. So let's see if we can find the bar. Database.find bar with the given name. And if it's none, then that means it was not found. When we did the dot first over here, well, there was nothing at all. So that first returned none. That means there were no results at all. And if that's the case, then we need to give an appropriate error. So we'll be using the make response function and saying no bar found with the given message and return a 404 error. That means, bar not found in this case. Otherwise, you can JSONify the bar result from our query and return that directly. If there is the value error raised from line 20, then we handle it here, saying return make response with the given string. That's going to be bar is not specified. And we'll say the status code is 400. All of these different status codes are just another way to indicate some type of error. If it's no status code, by default, it returns a status code 200, which means OK. 404 is not found. 400 is, I think, a client error, not sure. And then 500 would be an internal server error. So for all other exceptions, if something goes wrong on our server-side code, then we'll say it's error 500. And then, of course, the last route is going to be for finding all the beers cheaper than a given number. So this is where we'll be using the post request as an example. Note that there's no parameter here for the function because we didn't have any URL path parameters, but instead we'll just get all the data from the request body. So the request body is actually stored as a request.data, and it's going to be a string originally. So you'll need to get that string, which represents JSON, and then you'll need to convert it into a Python object. That's why we have json.loads. As you can see in the documentation, it deserializes the string, some instance containing a JSON document, and then provides it as a Python object. And that's what's going on here. So we'll get the string request.data, convert it into the JSON, from the JSON to the Python object, and we'll store it as body. And then we can reference the JSON request body and get all the different information, like the price, if you have some user's name, some information that they want, that they need to provide before you show them some data on your analytics. That's how you would do it. And once you have the max price, we provide it to our function database.filter_beers, and we just JSONify the result and return it. Okay, so with this, we discussed a couple important things. Executing requests, having parameters, making sure your data from the query conforms to different functions, such as the dictionary function, so there's no error, the dictionary function, or even the JSONify function. Never try to JSONify none. That might throw an error. So there was that, and then we also discussed defining different REST API endpoints for all the different calls you'll need to make and get the data that you'll need to show. Now let's run this and see it in action. So from within the virtual environment and the server folder, we'll need to say python app.py. And once things are running, I'm going to use this tool called Postman to show you. So the first one was just bar, and that's going to be a GET request. And here it is. So as you can see, this bracket, so it's a list, and each element within is some JSON object representing one item, specifically one bar. So each element has a property for each of the columns, the address, the city, license, etc. And if it's not null, then you would see the information right here. Now, if I wanted to filter, I can do that. So /blue angel, and I get only one element, and that's the entry for blue angel. Okay. And now for the last one, it's going to be beer's cheaper then. But here, let's actually, before that, I'll show you this error coming up for some error that doesn't exist. All right, there we go. So the message was no bar found with the given name, exactly what we expected, and the error code is 404, not found. Now, for beer's cheaper then, it was a post type. So instead of get, we'll change this to post. Go to body, and here's the body. You'll also need to make sure that this is specified. It should be JSON, not text. And when we send this, we should get all the beers with price less than 4.1, so $4.10. And here they are. Okay, that's pretty much it for this video. So we discussed how to execute SQL queries and return the resulting data back to wherever the request came from. In the next video, we'll begin creating the user side, so the front-end Angular application, and we'll be using the Angular CLI for that. All right, I'll see you guys in the next video.